Recording. All right, continuation of divisibility tests beyond 8. Does anybody happen to know of a test for 9? I lost my chat screen somewhere. Where did you go, chat? There you are. 9. Any takers? Sum equals 9. Right on. Yeah, so for 9, we sum the digits, and if the resulting sum is a multiple of 9, then the original number is a multiple of 9. So sum of digits is a multiple of 9. Yeah, so it may not add up to 9 exactly. It could add up to 18. It could add up to 27. Any multiple of 9 is fair game, and that would just depend on how many digits the number had. So for example, if we had the number 99927, and I add up those digits, 9 plus 9 plus 9 plus 2 plus 7, so what does that add up to? 9 and 9 is 18, another 9 is 27, 28, 29, 36 is that sum, and 9 goes into 36 4 times. So that means 9 must go into 99,927. Pretty cool. The reason is the same as the reason 3 has that ability, and I will explain that next class. 10 is pretty straightforward, ends in a 0. Does anybody know of a test for 11? 11's got a cute one. Nothing in the chat yet. All right, so I'm gonna put up an example and test it out. Pen. It's an alternating sum and difference, and there's a couple of versions of it. And so I'm going to go over the easy version of it. So suppose I want to know, does 11 divide 135,795? So what I do is, instead of adding them all up, I alternatively add and subtract. So if I write the 1 first, it is positive, so that's an addition. So next comes a subtraction, then an addition, then a subtraction, then an addition, and then a subtraction. So they have to strictly alternate sign. So I get it right? 1, 3, 5, 7, 9, 5, and then we have positive, negative, positive, negative, positive, negative. So we compute that right there. If 11 goes into the result of that, then 11 goes into the original number. So sometimes what we do is combine the positives and combine the negatives. So let's see, 1 and 5 and 9 is 15, minus 3 and 7 and 5 is also 15. So this comes out to be 0. And it turns out 11 does divide 0. 11 goes into 0, since 11 times 0 is 0. So that means 11 must divide 135,795. The reason that this works is similar to the reason for 9 and 3, and I'm going to save that for the next class. It's a bit complicated, but we'll take a look at it later. All right, moving on. Let's see, I think we'll stop at 12. So divisibility test for 12. Does anybody know of a test for 12? And you could look back at our other tests for a clue as to what a test for 12 could be. So which other tests might help? Here's some of our originals. Suspense is building. Don't be afraid to make a guess and be wrong. All right, we have no activity in the chat. Are you all still there? Can anyone hear me?
I'm trying to come up with something.
Yeah, it's hard. So that's okay. If you look at 6, we use the test for 2 and the test for 3. So let's think about that right there and how we might make a test for 12 based on other tests. So let's throw some suggestions there. What could we try? Six, we tested for 2 and 3. For 12, could we test for 2 and 6? Or maybe test for 3 and 4? Let's try and see what happens. So let's suppose we go with the 2 and the 6 test. So we'll pick a number we know 12 goes into and when we don't, and see if it works or fails. So if I go here and maybe I'm going to try 144. So the test for 2 is that it ends in a 0, 2, 4, 6, or 8. So we know that 2 divides 1,144. Now to test for 6, we'd have to test 2 again and 3. So as far as 6 goes, well, we already tested for 2. How could we test it again? That seems kind of weird. But we would have to test for 3, 1 plus 4 plus 4. Let's see, 4 and 4 is 8, plus 1 is 9. So so that means 6 goes into 144. So if 2 goes into 144 and 6 goes into 144, 12 should go into 144. Now we know, hopefully we all know, that 144 is 12 times 12. So it looks like the 2 and the 6 worked in that case. So there's one example where it worked. So let's try another one. Let's take 30. We know that 2 goes into 30 because 30 ends in a 0. And then 3 goes into 30 because 3 plus 0 is 3. So 2 and 3 go in, so 6 goes in, 2 goes in, but I can pretty much look and see 12 does not go into 130 because I know 12 is the first multiple of 12, 24 is the second multiple, and 36 is the third one. I missed 30. So checking for 2 and 6 worked here, but not there. Didn't work, so that's not going to work there. So the question is like, why didn't that work? Why not? Okay, we'll come back to that. Let's try 3 and 4. So let's see, we'll pick on the same two numbers, 144. So 3, does 3 go into 144? The answer is yes. We tested that earlier because 1 plus 4 plus 4 is equal to 9, and 3 divides 9. Does 4 go into 144? Let's see, well, does 4 go into 44? The answer is yes, because 44 is 4 times 11. So if we recognize that, then it works. So 4 goes into 144, 3 goes into 144, and we know 12 goes into 144. So the test did work here. So that's, yes, it did work here. How about 30? Let's test there. 3 divides 30. We already checked that. Does 4 divide 30? Well, 4 goes into 32 and 28, but it doesn't go into 30. 4 does not divide 30, which is a good thing, because that means 12 should not divide 30, which we know it doesn't from our work above. So it turns out the test was successful here. It showed us that 12 did not go into 130. So it looks like this test right here is going to work, but that one didn't. Okay. So again, where does this test come from? Well, we know that 12 is equal to 2 times 6, but it turns out we couldn't use that fact to make a new test. We know that 12 is equal to 3 times 4, but it turns out this is a valid test for 12. So does anybody have a thought as to why 3 times 4 worked to test 12, but 2 times 6 did not? Why was one product successful and one not? Any suggestions? The reason kind of came up when I was fiddling around right here. What is the test for 6? How do we test for divisibility by 6? Anybody?
You test for 2 and 3.
Yeah, we test for 2 and 3. The problem with the 2 times 6 here is that 6 is 2 times 3, and we have that 2 there. So 12 is equal to 2 times 2 times 3. So we kind of have to test for 2 twice in a row. But the way that would work is the first test for 2 basically divides a 2 out of 144, leaving 72. Once that 2 is gone, then we could test for 6. But we didn't do that up here. So using 2 and 6 is way more complicated than 3 and 4. So because 2 and 6 have a common factor, 2, it didn't work easily. But 3 and 4 have no common factors, so there was no confusion about who was dividing the 2 out. So 3 and 4 worked fine. So it turns out there are ways to modify this test I tried for 2 and 6 to get 12, but not the way I implemented it up there. So in general, we just say, nah, that's not really a good idea. It's a little more trouble than it's worth. So the key here, this test is valid since 3 and 4 have no common factor. And to be more precise, other than 1. 1's kind of boring. Okay, that's supposed to be a fancy 1. That did not come out very well. We'll just do 1 like that. So those are all the divisibility tests I wanted to go over. So we have explanations for some of them. We're still lacking an explanation for 3, 9, and 11, but we can see that they work for any example that we tried. Again, the reasons we'll come to later. What is next on our list?